Welcome folks, this is a continuation of Mathematics Paper 1 for the year 2019, and this paper was written by the internal candidate. So we have question 9a. A number is chosen at random from the set. We have numbers 1 up to 10. Find the probability that it is a perfect square. So say probability of perfect square. So what are we going to do? First, we need to identify the numbers that we consider to be perfect square. Now, the simple definition that I can assign to these numbers are numbers that we can find their square root without using a calculator. We can just say the numbers with a perfect square root. So in our case, we know the square root of 1 is 1, then the other perfect square number is 4, then we have 9. So from the numbers, we can see that we only have 3 perfect squares. So we just say 3 divided by the total number, which is over 10. So this is our probability. Then we move on to question B. Under question B, we are solving where the index is unknown. So 8 raised to the power x is equal to 128. So x represents a number that we can raise 8 to, so that we equate to 128. So what is our first step? So our first step is we need to make sure the two bases, these two bases must be the same. Now for us to come up with a base that we can have equal on each side, we see that 8 will not work. So what we are going to do is we can break 8. So 8 is same as 2 raised to the power 3, because we know that 2 times 2 times 2 is equal to 8. So 2 times 2 is 8, which is 2 raised to the power 3 is 80. Then we put our x outside here. So since we have the base 2, we also have to write our 2 here. Now, by what number can we raise 2 so that we are able to get the result of 128? So let's see. 2 times 2 is 4, times 2 is 8, times 2 16, times 2 32, times 2 64, times 2 128. So we want 1 2 3 4 5 6 7. So 2 raised to the power 7 is same as 128. Now after we have equal bases, we can now expand. So this is same as 3 times x will give us 3x is equal to, then 2 raised to the power 7. So whenever the bases are equal, then the powers also must be equated to each. So to find our final answer, we'll say 3x is equal to 7. We divide by 3, also here by 3. So x is equal to 7 over 3. If you want, you can try to prove. So if you want to prove, we know that it's 2 raised to the power 3, then times the x value is 7 over 3. So we know that we can cancel this. So this will give us 2 raised to the power 7, and 2 raised to the power 7 is equal to 128. We move on to question 10a. Set A is equal to prime numbers less than 12. List set A. So what are prime numbers? Prime numbers are numbers with 2 factors, 1 and the number itself. So the first prime number is 2, followed by 3, 5, 7. 9 is not a prime number. 9 has 3 factors. So our last number is 11. So this is the answer for part A. Now we move on to part B. The diagram below shows a sector A or B. Arc AB subtends an angle of 21 degrees at the center O. Given that the area of the sector is 18.85 centimeters squared, calculate the radius given pi is equal to 22 over 7. So what is our first step in our case? We need to write the formula. So area of a sector is equal to theta over 360 pi r squared. Then we are going to substitute. Where there is A, we substitute with the area given, which is 14.85 is equal to, the theta is given 21 over 360 times 22 over 7 multiplied by r squared. Remember, our target is to find the value of r. Then for this one, we need to find ways of how we can simplify our answer. So for 14.85 will be written like that. Then for 21, we know that 21 is same as 7 times 3. So I'm trying to find ways of simplifying our problem here. Then for 360, 360 is same as 180 degrees multiplied by 2. Then 22 is same as 11 times 2 over 7 times r squared. But my point is, if this seems to be hard for you, you can use the usual ways. So what numbers can we cancel? So we can cancel these two here, we can cancel these two here, we can cancel 7, we cancel 7 here. So that I have 14.85 is equal to, on top we have 3 over 180, then multiply by 11 times r squared. So 3 into 3 is 1, 3 into 180 will give us 60. So we have 14.85 is equal to 1 over 60. Then you say 11r squared. So over 1, we cross multiply. 1 times 11r squared is 11r squared. Then here we need to find a product of 14.85 times 60. So what do you do? So for this number, we know that since the number that we are multiplying has a 0, so we can move the decimal to the right. So we have 148.5. Then for this number now, we are going to multiply by 6 since the 0 has done its work. So let's ignore the decimal. Let's just say 1485. Let's multiply it by 6. So let's see the results that we are expecting to get from here. So 6 times 5 is 30. So we write 0. We keep the 3. Then 6 times 4 is 24. 24 plus 24, that is 48. 48 plus the 3 is giving us 51. So it's 1. We keep the 5. Then 4 times 6 will give us 24. 24 plus 5 is 29. So 29 will keep our 9 here. Then 6 times 1 is 6. Then plus 2 is 8. So it is 8,910. Now remember, we ignore the decimal here. So the decimal is here. So which is 11r squared is equal to 891. Then we divide by 11. We also divide by 11. So can 11 go into 891? So what do you do in a case where you do not have a calculator? Like for the given question, we do not have a calculator, so we need to check. So what do you do? Okay, so let's try. So 11. So let's now divide. We'll first pick these two numbers. 11 into 88 is 8. Okay, remainder 1. So 11 into 11 is 1. Then we take the square root. Also here the square root. So radius is equal to 8 centimeters, not 8 but 9. The square root of 8, 1 is 9. So this is how we can simplify this question. Okay, we move on to question 11. The diagram below shows the positions of towns A, B, and C on the Earth's surface. if it is 0820 at A, what is time is it at C? So at A, meaning the longitude in line with point A has the time of 0820. Then our task is we want to find the time at C. So what are we supposed to do? We need to find the difference in longitude. So that is the first step that you are supposed to do. Find the difference in longitude. Now we need to look at the longitude for point A is 20 degrees east. Then for point C is 95 degrees east. So we need to subtract since they are on the same position. So 95 minus 20. So the difference here will give us 75. Now remember, 1 hour is equal to 15 degrees, which means that if we make our calculations here, we cross multiply. 15 degrees multiplied by x is 15 degrees x. Then this will give us 75 degrees hour. We divide by 15 degrees, we divide by 15 degrees. So x is equal to 15 into 75. This will give us 5 hours. Okay, so the simplest way to simplify what I've just said here is that whenever you have found the difference in longitude and your target is to convert that difference in longitude into hours, just divide by 15. So 15 into 75 will give us 5, because 15 plus 15 is 30, plus 15, 45, plus 15, 60, plus 15, we have 75. So which means that the difference in hours between point A and C is 5 hours. So whenever you are finding the time ahead of a given point, you need to add. So 0820 plus 5 hours is what we are supposed to do. We are adding. Then if you are looking for the time behind, you need to subtract. So here we get 13. So the time at C is 1320 hours. Then we move on to question B. A plane flies from point A to B at a speed of 400 knots. How long does the journey take if AB is equal to 4,800 nautical-miles? So say speed is equal to distance divided by time. So we want how long, so it's t. We are solving for the value of t. Over 1 we cross multiply. So st is equal to d over s over s. So if you want time, we'll give you distance divided by the speed. What's our distance? We are given it's 4,800 nautical miles. Then what of the speed? Speed is given 400 knots. So we can cancel the zeros. 4 into 4 is 1. 4 into 8 will give us 12. So it is 12 hours, because 12 times 4 will give us 48. Excuse me. We move on to question 12. Question 12. The length of a piece of wire is measured as 4.5 centimeters. Calculate the tolerance. So to find the tolerance, first we need to find the upper bound. So is equal to upper bound minus lower bound. Now how do we find the upper bound? We need to find the absolute error. Now let's look at the number of decimal places that we have. So we only have one decimal place. So whenever you're dealing with a number correct to one decimal place, then the absolute error is 0.05. So this must just be committed to memory. So say we now move on to find the upper bound. So the upper bound is found by adding the given true value plus the absolute error. So as you are adding, make sure that the decimal places are in line. So 0 plus 5 is 5. Here we still have 5. So the upper bound is 4.55. Then the lower bound is found by subtracting, which is 4.50 minus 0.05. So what you do, you get a 1 from 5, you put here, you have 10. 10 minus 5 is 5. Here we have 4. 4 minus 0 is 4. So the lower bound is 4.45. So the difference between these two numbers is our tolerance. So 4.55 minus 4.45, this will give us 0.1 centimeters. So this is our tolerance. Then the other question is the relative error. So relative error is given by absolute error divided by true value. So this is a ratio. You don't have to show the units. So the absolute error is the number that we gave according to the number of decimal places, which is 0.05 centimeters over the true value is the number given in the question, 4.5 centimeters. So we have to cancel these. That's why we said it's a ratio. Then from there we have 0.05 over 4.5. Now under mathematics paper 1, where you don't have a calculator, it's hard to divide decimals. So what are we supposed to do? We need to get rid of the decimal. So we are going to consider the lowest number between the two numbers. So the lowest number is our numerator. We need to count the decimal places. So it's 1, 2. So this number we multiply by 100. Then we do the same to the denominator. So 0.05 times 100 is 5 over 4.5 times 100. It means the decimal will move to the right 2 times. So this will give us 450. Then we can reduce 5 into 5 is 1. 5 into 45 will give us 9. So it's 1 over 90 as our final answer. So we move on to question 13. In the diagram below, A, B, C, and D are points on the circumference of the circle. Center O. DAT is equal to 40 degrees, BDC is equal to 30, and AT is a tangent to the circle at A. Now, whenever you're dealing with circle theorem, make sure you've mastered the 8 properties that we are given in textbooks. So now let's look at the first question here. So the first question is we want CBD. So CBD. So this angle. So what angle is this angle? CBD. So what are we supposed to do? Let's go back here. Now, if you look at the given data, O is the center. BD, this line BD is a diameter. And we know that a diameter cuts the circle into 2 halves. So if this is the diameter, then a triangle BCD is a right angle triangle, meaning here we have the angle of 90. Remember, angles in a semicircle adds up to 90. So that's the point. So whenever you have this point, as long as there is a diameter, a line that passes through the center, which is the center O, then the principle of semicircle must be used. So to find CBD, we just say 90 minus the given angle, which is 30. So this will give us 60 degrees. So at this point we have 60. So that 60 plus 30 is 90, plus this 90 here, we have 180, which is a triangle adds up to 180. Then we have BAC. So BAC, this angle. So this angle, we use the principle of angles in the same segment are equal. Look at this point. So this angle here is 30. What of this angle? Here will also be 30. Why? These 2 points, this point and this point, even these 2 points are originally on the same point. Even these 2 are also starting from here. So this angle here and this angle here must be equal, which is angles in the same segment are equal. So even here we have 30 degrees. So BAC is equal to 30. Now move on to AOB. So let's look at where there is AOB. This angle here. What is angle AOB? So how can we find this angle? So for us to come up with this angle, remember we have been given this 40 here. Then this line AO is a radius, and whenever a radius meets a tangent, this tangent here, they make an angle of 90. So this angle, this total angle here is 90. Now if this is 90 and here we are 40, this angle must be 50, because 50 plus 40 is 90. Then if this is a radius, this is also a radius. So the distance from O to D is a radius, from O to A is a radius. So if these two are radii, then these two base angles are equal. Even here we are going to have 50. So if these two angles are equal to each other, what are we supposed to do to find this angle? We need to add. So 50 plus 50, then we put x here. So we'll say x plus 50 degrees plus another 50 is equal to 180. So x plus 100 is equal to 180. So if we collect the like terms, if 100 shift to the right side, becomes negative 100, which is x is equal to 80, which is at this point is 80. Now if this is 80, then this angle is equal to 100. Remember, a straight line adds up to 180. So 100 plus 80 is 180. So angle AOB is equal to 100 degrees. We got to question 14. In the diagram below, BCD is a straight line, AB is equal to 12 centimeters, AC is equal to 20 centimeters, and angle AB is equal to 90. Find the value of cos ACD. So we want this. Now this is an exterior angle. So we can't go direct to find the exterior angle. We are supposed to find the interior angle, which is we need to find this angle. So how can we find this angle using the trig ratios? So what we are supposed to do is we are going to introduce the concept of SOHCAHTOA, trig ratios. So if this is our angle of interest, then this distance is opposite, then adjacent we have hypotenuse. So if you look at the SOHCAHTOA, our interest is cos. So we are going to look at CA. So CA is cos theta is equal to adjacent divided by hypotenuse. So say cos ACB. Remember, first we are finding the inside, which is ACB. That is what we are finding here. Now for us to find this angle, we need the distance of adjacent. So this adjacent is not given, but the hypotenuse is given, which is 20. So how can we find the adjacent? We introduce now the Pythagoras theorem. So according to Pythagoras, the formula is c squared is equal to a squared plus b squared. So the c squared is h, then a b. Now if we are looking for one of the two shortest distances, so we'll just say, since in our case we are finding for b squared is equal to c squared minus a squared. So b squared is equal to c squared is this distance 20. So we have 20 squared minus a squared is 12 squared. So b squared is equal to, we have 400 minus 144. So what is 400 minus 144? So we need to do some math here. So let's put it here. So we have 400 minus 144. So here we have 10, 9, 3. 10 minus 4 is 6. 4 minus this one is 5. 3 minus 2. So the answer is 256. Now, what is the square root of 256? So the square root of 256 is 16. So here you introduce the square root also here. So it is 16. So it means at this point we have 16. So this is the number that we are supposed. So cos SCB is equal to, we can reduce 4 into 16 is 4 over 4 into 20 is 5. Now remember, our target is we want cos ACD. So whenever you have the inside angle and you want the outside angle, you just introduce the negative sign to this. So this becomes negative 4 over 5 is our final answer. We have question B. A and B are points with coordinates negative 3,3 and 5,9 respectively. Find the length AB. So distance is given by the square root x2 minus x1 squared plus y2 minus y1 squared. So A has negative 3,3, B has 5,9, x1, x2, y1, y2. So let's do the substitution. So what's our x2 is 5 minus x1 is negative 3 plus y2 is 3 minus 9 squared. So if we simplify the first bracket, it will give us negative times negative is positive 3 squared plus here we are going to get negative 6 squared. So what is 5 plus 3 is 8 squared plus negative 6 squared will give us 36. 8 squared will give us 64. The sum of 36 and 64 is 100. So we know that 100 is a perfect square number, has the square root of 10 as our final answer. So say 10 units since its length. Then we move on to question 15. A varies directly as B and as the square of C. So let's begin by writing our, so we have A varies directly as B and the square of C. So the C must be squared. So there is nothing like inversely. So the letters A, B and C will all be in the straight line. So say A is equal to, then we introduce K times B times C squared. So question A, find the value of K, the constant of variation. What's our A? 30. K is what we are solving for. What's our B? 2.5. Then what's our C? 2 times 2 since it's 2 squared. So what do you do? First we will divide by, let's remove 2, we divide by 2, also here by 2. So this is one of the ways in which we can simplify. So 2 here, 2 here, 2 here, we know that will give us 15. So on this side we have 2 times 2.5 times K is equal to 15. Then what do you do? So we divide by 2, also here by 2. So I have 2.5, K is equal to 2 into 15 will give us 7.5. So over 2.5 over 2.5. 2.5 into 7.5 is 3. Or if you want, we can just do this. So we know that we have 2.5 times 2 times 2 is equal to 30. So if you want, we can get rid of the decimal by multiplying everything by 10. So if you multiply by 10, this will give us 25 times 2 is equal to 300. So then we have, okay, we divide by 2, also by 2. So you know that 25 times 2 is equal to 150. So 25 times 2 is 50k is equal to 150 over 50 over 50. 50 into 150, we are still getting 3. Then B, the value of A when B is equal to 2 and C is equal to 3. So the formula is A is equal to KB C squared. So the value of A is what we are solving. What's our K? 3. B is 2. Then what's our C? 3 squared. So 3 squared is 9. 9 times 2 is 18. Then 18 times 3. 3 times 8 is 24. We keep the 2. 3 times 1 is 3 plus 2, 54. So 18 times 3 is 54 as our final answer. Then question C, value of C when A is equal to 300 and B is equal to 4. So A is equal to KB C squared. So what's our A? 300. What's our K? 3. What's our B? 4. Our target is to find C. So let's divide by 3. Also 3. So that I have 4C squared is equal to 3 here. 3 here is 100. So we can divide by 4. Also here by 4. So C squared is equal to 4 into 100 will give us 25. The square root will just be C is equal to plus or minus 5. So this is how we can solve this question, and we're just going to end on this question. So that's it for this video. Thanks for watching.